Okay, this is the law. However, we're going to put off to the side, the law also works backwards. If your negative exponent happens to be on the bottom of a fraction, so all I've done is really switch this, this can equal just x to the n. Okay, so it's the same law, it's just backwards. So the way I think of the law is it doesn't matter where the negative is, it's going to go to the opposite place. So if the negative is on the top of a fraction, it ends up going to the bottom and turning positive. If the negative is on the bottom, it comes to the top and ends up turning positive. So negative exponent changes where it is in the fraction. If the negative is in the denominator, it becomes the numerator. If the negative is in the numerator, it becomes the denominator. Okay, so all we're going to do is rewrite this so it has positive fractions. We don't care about the value. It's not what the question is asked. It just says rewrite it. If we look at that -3 that's on the 2 is in the top or the numerator, so where is it going to go? To the bottom. So I'm just going to move that 2 to the bottom and change the exponent positive. That's the negative exponent law. The 5 has a -6. If it's already on the bottom, where am I going to move it to? The top, and it becomes positive. That's negative exponent law. If it's in the denominator, it moves to the numerator. Numerator moves to the denominator. 1/3 to the -7. Right now, the exponent is negative. I don't like that. I want to change it. If it's in the denominator, where is it going to go? Up to the numerator. What happened to that 1 that was there? Well, what happens when we multiply anything by 1? It just stays the same. So that's this law right here. It's the backwards law. So 1/3 to the -7 becomes 3 to the -7. Let's just confirm that, because that looks crazy when you look at it. So in your calculator, give me 3 to the 7. Probably a pretty big number. 10,000? 2,100 and blah, blah. Now give me 1 divided by 3 to the -7, which your brain probably thinks is a small number because it's divided by 1, but watch what's going to happen. 1 divided by 3 to the -7. It's the exact same thing. Okay? That's why we have negative exponent law, because this freaks us out. This makes us happy. 3 to the 7 we like seeing. If we get something like this, bah, we don't like it. Negative exponent law is a way to change exponents positive. The law basically says if it has a negative exponent and it's in the top, it's going to go to the bottom. If it's in the bottom, it's going to go to the top. 4 to the -2. Well, again, this has a little minus or a little imaginary 1 underneath, so we can think of it like it's on the top. Put the phone away, please, Lexi. But you can't have your phone out without looking at it. That's not your phone? Oh my God, it totally looks like a phone. I apologize. It's on the top right now, so where is it going to go? To the bottom. Well, I can't have the top there with nothing hanging around, so what am I going to put at the top? 1. That's the law as it's written. 4 to the -2 becomes 1/4 to the 2. How does it work with fractions? Exactly the same way. This whole fraction right now is on the top, so it's going to go to the bottom, and the exponent is going to turn positive. Exponent law number 7, negative exponent law is just a way to turn negative exponents positive, because we don't like them being negative. They're hard to calculate. They don't make a lot of sense. We like them being positive. Okay, now we're going to go one step further, and we're actually going to evaluate without our calculators. So put them away. Grab your paper. Negative exponent law. So we actually already did this one at the beginning when I was getting to evaluate values with your calculator. Now we're going to do it without. Step number 1 is when you have a negative exponent, you have to turn it positive. Negative exponent law says if it's on the top and the exponent is negative, it's going to move to the bottom. So this is going to go down and become positive. What's got to go on the top when there's nothing else there? A 1. So step number 1 is use the negative exponent law. Now we're just going to evaluate what is 4 squared? 16. So 4 to the negative 2 equals 1 over 16. 5 to the negative 2. First thing we're going to do is change it positive. Negative exponent law says if it's on the top and it has a negative exponent, it goes to the bottom. What goes on the top when there's nothing else there? And the last step, we're just going to evaluate what is 5 squared on the bottom. So 5 to the negative 2 equals 1/25. 2 to the negative 3. Again, what your brain is going to want to do is one of two things. You're either going to want to write this down as -6 if you really don't understand exponent laws. If you do get exponents, you're going to want to put -8. What have I done here to get -6? What's the incorrect math that I've done? I just multiplied 2 times -3, and we know that's not the way the exponents work. What have I done here? What's the incorrect math? I did 2 to the 3 and then just made it negative. That's not what the negative exponent law says, so I'm going to cross both of these out. If you think you might do that, you might want to put those in your notes and cross them out. Some people don't like incorrect work, so it's up to you. But those are the 2 most common mistakes. It's what your brain is going to want to do when you're in exam panic and you're just trying to get through these questions. Negative exponent law is how we evaluate them. Negative exponent law says if the exponent is negative and it's on the top, it goes to the, I've said this like 50 times already, to the bottom. Which is a side note, why do I keep repeating it? Who needs that? Auditory learners need to hear. If there's nothing else on the top, what magically appears on the top? And now we just evaluate this, so this would be 1/8. Mathematically, is there a difference between -8 and 1/8? Huge. This is a huge difference between these two numbers. This one is really, really small, close to 0. This one is big and negative. That's why we have the negative exponent law. Oh, remember yesterday when we did rational exponents? Guess what? They can be negative. Thank you for that. We do the negative exponent law first because we need to turn it positive. Negative exponent law says if it's on the top, we move it to the bottom. If there's nothing else on the top, what do we put on the top? So this becomes 1/16 to the 3/4. Now we're going to evaluate yesterday just like we did yesterday. So we grab the bottom number first. What does it mean? What's the bottom number? The tree, the bottom, what's the bottom number? The root. So this is the 4th root of 16. So you've memorized from the table, you're thinking, what is the number times a number times a number times a number that gives us 16? What is the 4th root of 16? 2. What do I do with that little 3 that I haven't touched yet that's just hanging around there? I just copy him down. Casey, this is all yesterday's stuff. Now the last step, I just do that 2 to the 3, which is 1/8. So now without your calculator, you can evaluate what the heck is 16 to the -3/4. It's 1/8. Essential kids can't do that. Show me your thumb. How are we feeling so far? Getting, kind of getting, good. 8/27 to the -4/3. Imagine we'd given this to you last year, you would have cried. We do the negative first. We take care of the negative by using the negative exponent law. Negative exponent law says if it's on the top, it's going to go to the bottom. What goes on the top if there's nothing else there? Write down what this would become with the negative exponent law. Just compare with someone sitting around you. If you have the exact same answer written down, high five. Yeah. No, just that first step. We're just doing one step. This is what you should have, and make sure you've kept those brackets, because that exponent is going to apply to the 8 and the 27. Did he high-five while holding a pencil? That could be very dangerous.
He turned it backwards so I didn't hurt myself.
Questions so far in the first step? Now we're going to evaluate. This is from yesterday. We grabbed the bottom first. What does the bottom number represent? The root. Okay, so we need to do the cube root of 8 and the cube root of 27. Remember, with a fraction, we just do top and bottom. What is the cube root of 8? What's a number times a number times a number that equals 8? What is the cube root of 27? Number times a number times a number that equals 27. I'm going to still keep those brackets. And what do I do with this 4? I just copy him over. Haven't touched him yet. Next step, I'm going to deal with that exponent. Again, if we have a fraction, exponent applies to the top and the bottom. So I need to do 2 to the 4 and 3 to the 4. We've memorized those off the table. 2 to the 4 would be 2 times 2 times 2 times 2. I heard a little quiet offer of 16. 3 to the 4 would be 3 times 3 times 3 times 3. 81. And the last step, I just need to simplify this, because this is called a complex fraction. Complex fractions means you have a fraction in a fraction. So this is just a simple division of fractions. What do we do with division of fractions? What do we do with the second fraction? You learned it in grade 8. You learned it again in grade 9. We take the bottom fraction and we... And what do we call that? What's a vocabulary word when we flip a fraction? Rhymes with nothing. It's called the reciprocal. Okay. So I'm leaving this 1 for now. I'll deal with him in a second. All I'm doing is taking that bottom fraction and flipping it, taking the reciprocal. Does anything rhyme with reciprocal? No, can't think of anything. Popsicle? Yeah, maybe. And so the second fraction is going to become 81 on 16. I've just physically flipped it. And then what happens if I multiply by 1? Okay, so the final answer is 81 over 16. That's as hard as they're going to get. But think when you practice a little bit, you're going to be able to calculate this without a calculator and figure out that it's 81 over 16. Seriously, you could take this on the road and charge people money to watch this. Questions so far? 2 to the negative 3 and 5 to the negative 2. We simplified this one already on the other page, but we'll do it again. So we're going to simplify, then we're going to evaluate. I'm just going to look at these independently. So I'm just going to look at this 2 to the negative 3 first. I'll worry about the 5 and everything else later. This is on the top of the fraction. So negative exponent law says it's going to move to the bottom. This question, what's different is I've got something on the bottom. Well, if it's on the bottom and it's negative, it's going to move to the top. So the only difference from the other ones is I don't have that 1 on top because I've got something else that needs to go there. Now we're just going to evaluate. What's 5 squared? What's 2 cubed? Done. Why do we need to know this math? Well, here's an example from chemistry. Read. If it was not for chemists, you would have nothing but water to drink and nothing would taste like anything because there'd be no spices. Thank your chemists. When you read to just read it, what did you get out of the question? Temperature, maybe something with time. That's all you're going to get the first time through. It is really important on the exam especially that you are doing this 2-step reading process, because what the first time does is just give you a context, and what happens is you start to picture it, think about it, then the second time through you're picking out the information. If you're trying to understand the first time through, there's too much going on in your brain. Okay, what do we actually need to know? What's important in this question? Cooling temperature, and they've defined it as capital T. the formula. Little t is time and minutes. 10 minutes, 20 minutes. We usually want to find what the question's asking. What temperature? We're going to pause, make sure we have all the information. So either close your eyes or look up, your choice. I'm going to read out what we've highlighted. You're going to tell me if we have enough information. Cooling temperature, capital T. Capital T equals 40 times 10 to the negative 0.1 small t, where small t is the time in minutes. What temperature? 10 minutes, 20 minutes. Do we have all the key information? Okay, what do we do? Answer it. Yes, I would love to answer it. Tell me how. I will write down whatever you tell me to write down. Apple. Banana. I almost put an extra N. I was thinking minions. Math. I can't do it. Can't. Apples suck. Okay. The formula. What? T equals. Capital T equals. She said above. I put it above. Oh, to the power of. Oh, okay, I'm with you. Capital T is 40. I really am. To the power of, yes? 0.1. 0.1. Yes? Okay. I don't know. You tell me. Okay. Oh, no, you do not need a calculator for this. Bed math. Okay, what would you like to do in the brackets first? Okay, probably want to simplify this guy here. What's 10 times negative 0.1? Okay, after brackets, exponent. It's a negative exponent, so that's negative exponent law that says if it's at the top and the exponent is negative, it goes to the bottom. What goes on the top if there's nothing else there? You're still bed massing. We did the brackets. We did that here. Okay, how do we multiply fractions? Really, grade 8 and grade 9, we've done before. No, we do top times top and bottom times bottom. For what? It's a word problem. We are so not done. For goldfish, for dollars, 4 degrees. What's the units if it's not specified? Degrees Celsius. From a chemist's point of view, why does that exponent need to be negative? because this is cooling off and it's the only way to decrease the temperature. That's what the negative exponent is doing, is making it cooler. Did this thing get cooler? Yes. Go ahead and show me for 20 minutes. No calculator, you're smart, you don't need it. That's why I have confidence for you. Okay, I did the first step. You can take it from here. Or not. Okay, multiply up here. -2, I heard. Okay. Either or. I'd accept both. Who got it? Awesome.